Hello, good day viewers. In this tutorial, we are going to find a solution to this interesting question. We are given that if use of n is equal to 3 multiplied by 2 divided by 3 raised to the power of n minus 1, we are asked to show that use of n plus 1 is exactly the same thing as 2 multiplied by use of n. You already know what is use of n. This is use of n minus 1 divided by 3. All right, let's get started. This is what I would like to take, simplify it, and show that it is the same thing as 2 multiplied by use of n minus 1 divided by 3. So let me bring it down here. If use of n is equal to 3 multiplied by 2 divided by 3 to the power of n minus 1, what do you expect use of n plus 1 to be? It will be use of n plus 1. Wherever you have n, you replace it with n plus 1. So this is the same thing as 3 multiplied by 2 divided by 3 raised to the power of n plus 1. You see, we have n here, we have n here. So we're going to have n plus 1 right here. N plus 1, then minus 1. So this is exactly what we need to simplify and show that it is the same thing with this. According to one of the laws of indices, we can split this because we have 2 divided by 3 raised to the power of n plus 1. Can you remember? It can be written as 2 divided by 3 to the power of n, then multiplied by another 2 divided by 3 to the power of 1. You know, when you have common bases and you're multiplying them, you take a single base, then you add the exponent. So this is the same thing as 3 multiplied by 2 divided by 3 to the power of n multiplied by another 2 divided by 3 to the power of 1, which you don't have to write, then minus 1. If you take this 3 and multiply it by 2 divided by 3, you are going to obtain exactly equal to 2, right? So we have this to be 2 multiplied by 2 divided by 3 to the power of n minus 1. But you should always remember that we want to end with an expression that has a denominator of 3. So I can do something here logical. You know, whatever expression you multiply by 1, it remains like that. So if I should multiply this by 3 divided by 3, you know, 3 divided by 3 is the same thing as 1. So it's like we are multiplying the whole of this expression by 1, which will not change anything. We'll end up having 2 times 3. I can use the numerator, which is this, to distribute over this expression and leave 3 as our denominator. So 3 times 2 will give us what? 6. Multiplied by what? 2 divided by 3 to the power of n minus 3 times 1 is 3. Then the whole of this divided by 3. So now our denominators are exactly the same. Then we want to arrive at what? 2 multiplied by use of n. How can we do that? We know that 6 is the same thing as 2 times 3. And negative 3 can be written as negative 2, negative 1. Negative 2, negative 1 is negative 3. So I would like to write it as 2 multiplied by 3, then times 2 over 3, raised to the power of n, minus 2, minus 1. Logical. The whole of this divided by 3. So I would like to group this, because they have what? Something in common. They have 2 in common, so I can factor it out. We can continue to the other side. So we bring to our side, then inside we're going to have 3 multiplied by, let me come to the other side, 2 divided by 3 to the power of n, which is this one. Then here we have minus 2, but 2 is already out. We still have minus 1, right? But we have another what? Minus 1 right here. The whole of this divided by 3. So what can you remember about this expression? 3 multiplied by 2 divided by 3 to the power of n minus 1. It is exactly as use of n. You see that? 3 multiplied by 2 divided by 3 to the power of n minus 1. So we replace this with what? Use of n. 2 times use of n. This is 2 times use of n. Then we still have minus 1. Then divide by this 3. And hence, we have just shown that the whole of this expression is the same thing as this. You see that? We have shown that they are exactly the same. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.